Present here. My research topic on supplementary cementitious blend of metakaolin nanosilica with ferrochrome slag as fine aggregate in concrete. Guided by Dr. Punra, myself, Manigandan, research scholar. Based on stat, as per US Geological Survey report, India produces nearly 330 million tons of CO2. From this carnivore et al., we expels nearly 861 kg of CO2 per ton of cement production in both compaction and production process. So we have to reduce the consumption of cement. So we have been used partial replacement of cement as metakaolin and nanosilica. And coming to the slag on ferrochrome slag is sand. Stainless steel production, India produces nearly 124 million tons. So we are the second leading producer of stainless steel. From that, we produces globally 14 million tons of CO2 as per 14 million tons of ferrochrome slag as per ICDA report 2017. So we have to use the ferrochrome slag as fine aggregate. This is the major part of our project. This is the causes of our four causes of our project. And based on research gap, air-cooled ferrochrome slag is not used as a fine aggregate from the Indian origin slag. And we have to use in both high strength and normal strength concrete using the FCS. And later study on FCS has been not studied and so far. And we have to conclude that. And coming to the objectives, metakaolin and nanosilica to be used as SEMs as a replacement of cement. And coming to second phase, ferrochrome slag sand has been used as fine aggregate. This properties has to be examined for both M40 and MM grade of concrete. The health effects to be verified by using the leaching study, and solid blocks with cost effectivity and energy effectivity has been carried out. This is the various methodology we have been done so far. And coming to the fresh property, while replacing the metakaolin 8, 10, 12 and nanosilica of 0.51 and 1.5 replacement, there is a decrease in fresh property. This is due to the um, high surface area of the materials, minerals, what we have been using. And coming to the ferrochrome slag replacement also reduces. This is due to the porous nature of slag. Coming to the strength property, where we can see the 40% replacement of FCS, 40, 60, 60 CSAN, which enhance the better interlocking and gives the highest strength even in 365 days. And coming to the which reflects in the durability results, where we can see the FCS 40 as high density, and it also allows the high pulse velocity to passes. And in later age also, the hydration which reflects in this results. And coming to the water permeability, which is related to the connectivity of pores, the connectivity of pores has been reduced until the 60-40 proportion of the ferrochrome slag and C-sand. And the water absorption also follows the similar pattern. And RCPT value, while replacing the ferrochrome slag, it reflects slightly increases. This is due to the conductive ionic species present in the slag. And coming to the sophisticated study, where we can see the RC mix, AFM of flower petal shape and AFT of 18Z needle shape has been noted, and with a gap as ITZ. And while replacing metakaolin, it has been interlinked, and the low density cases has been formed. While replacing the nanosilica of optimum, we get the amalgamated ITZ. While the optimum mix, where we can see the rigidified ITZ with the dense CSH, where we can be witness why the strength has been degraded while replacing the 100% ferrochrome slag. This is due to the splatterness shape of low density CSH, which is similar pattern for Tekin et al. And Professor Hartley in 1972. Similar pattern where reticular networking system. This is the reason why the strength losses in the complete replacement. While coming to the 60-40 proportion, there is a low calcium silica and calcium silica alumina ratio. And coming to the TGA report, our optimum mix shows low dehydroxylation and decarbonization peaks. And this is the strength gain reason. Coming to the leaching study, where we can see the leaching on 64 days is within the limit as per US EPA and UK England Wales Agency report. So it won't causes the harmful health effects to the humans by leaching the total chromium. Coming to the solid block, based on the various concrete testers, we have been concluded that only 40% and 60% of CSAN can be replaced, and we cannot able to replace completely. So we have been gone for load bearing structure replacement for these various replacements. And coming to the strength study, FCS 100% shows the better strength than the other replacement, and water absorption also within the limit as per IS 2185 Annex E. And coming to the cost analysis, it saves nearly 9 rupees per block, including the GST. And coming to the embodied energy, it saves nearly 53.2% for FCS 1000 block. And coming to the this is the real-time application. We have used these blocks in the structure, load-bearing structure in the district of Krishnagiri, and this is the various project. This is the conclusion. Well, this is due to the interlocking action of 60-40 proportion of M sand, ferrochrome slag and C sand residifies the ITZ and well compacted microstructure and spiderness shape are the reason for the strength gains in the complete replacement. Durability also 40% performs better. Leaching also uh, uh, perform good, and the solid blocks also with a precise mixing methodology we get we will perform affordable solid blocks, and this is these are the various forcible probing research areas can be done, and these are the some of the journal publications, and patent for a method of producing solid block has been published, and this is the award from the NIT and other institutions for our papers, and this is the funding I have to thank for acknowledgement.